So today we will discuss our new chapter, which is chemical kinetics, right? So here the word kinetics means motion, or you can say dynamics, right? Basically this chapter deals with all the irreversible reactions, with irreversible reactions, right? Actually in this we will study about the rate of change, like basically we will discuss the changes with rate of change of concentration in a chemical reaction. We will study about the changes in concentration, and we can call this concentration as active mass as well, right? Active mass, like changes in concentration in chemical reaction with respect to time, that is basically known as chemical kinetics. Basically in chemical kinetics we will study about the how the changes are occurring, like we will basically study the rate, or you can say the velocity of how the concentration is changing with respect to time, right? Basically there are changes in concentration of the reactant, of the changes in concentration of reactant, right? We consider that we have a reaction which is A is being converted into B, right? Okay, so as I told you before that we will study only about the irreversible reactions in this chemical kinetics. Like in chemical equilibrium we studied about the reversible reactions, but here chemical kinetics, where we'll see about motion, about dynamics, like how the concentration is changing with respect to time. So here we will talk about the concentration of only the reactant, and here the equation will be irreversible. Basically the reaction will be irreversible reaction. Consider if you want to find a rate, like the velocity. So rate of reactant, so it will be minus del x upon del t. Now what is this? Basically del x shows us the concentration and del t shows us the time, like the change in concentration with respect to time. And this negative sign is showing that obviously when the reactant will get consumed, then the product will make. So that's consumed, like the reactant is being consumed, that is shown by this negative sign. This is also known as, you can say, rate of disappearance. Rate of disappearance. This is known as rate of disappearance, right? Now okay, let's consider and write the equation for the product. Okay, rate is equal to, here we put positive. Why? Because product is being formed, that's why. So delta x upon delta t, and this is basically known as rate of appearance. This is known as rate of appearance, right? Now let us talk about the rate of reaction. Basically we have different kind of reactions. Let's talk about the rate of reaction, right? Okay, basically we have different kinds of reaction. Let us first discuss about the fast reactions, right? Or we can say basically why they are known as fast reaction, because their time duration is very slow, very low. For example, they are 10 to the power minus 6 second or 10 to the power minus 12 second. 10 is power minus 6 second or 10 is power minus 12 second is their time period, is their time time duration, right? Or you can say basically if we talk about the examples, okay, for instance we have all the neutralization reactions, right? We have combustion reactions as well, combustion reactions, and explosion reaction like nuclear bomb and all that, explosion reactions, explosion, and precipitation reactions as well. Precipitation reactions, basically we can say all the ionic reactions, ionic reactions come over in this category. Okay, like have you wondered why these reactions are so fast? Basically the reason behind this that there, like if you talk about the reactant, basically the activation energy of reactant is very low. Why it is low? Because so there can be effective collision, there can be effective collision. Basically if there will be effective collision, so as the speed will be low, like as the activation will be, energy will be low, so they can easily collide and the reaction can be formed. So that's why they are known as fast reactions. Basically we can't calculate the rate of reactions of such compounds, of such reactions, we can't calculate the rate of reaction of such reactions, such fast reactions, basically fast, such fast reactions, right? So now we will talk about the second type of reaction, which is basically moderate reactions. Moderate reactions. For example, we have hydrolysis of ester. Hydrolysis of ester. Basically, we will say can say that here we have reversible reactions. Right. Now we have third type of reaction, which are known as slow reactions. Basically they take a lot of time to proceed, lot of time to proceed. They can even take years, they can take days or months as well in order to start or to proceed. Okay, if we look into the example, we have, for example, we have formation of diamond. We have formation of diamond, we have curding of milk, we have curding of milk, and we have rusting of iron. rusting of iron. Then we have formation of coal, formation of coal, right? Basically in the absence of air, in the presence of a lot of pressure and temperature. Now if we look into the rate, what is the unit of this rate? Like we are talking about the rate. Okay, basically before moving ahead, have you wondered why these reactions are so slow? Basically they are slow because the activation energy of such reactants is very high, so there can't be like a effective collision is very slow. It's slow. That's why they are slow reactions. Now let's talk about the what is the unit of this rate. The rate we are talking about. What's the unit of this rate? Right. We know the formula of rate is basically del x upon del t. Right. Now let's look into the unit as well. Now del x, which is concentration. So the unit of concentration is basically mole per dm cube, and the concentration and the unit of time is basically second. So the unit of rate is mole dm cube second inverse. If I ask you to write in the terms of gaseous, for the gaseous reactants, then it will be rate atm second inverse. This can be, and another unit for the gaseous can be torr second inverse, right? So I hope this is clear to you. If you have any kind of queries, you can ask me in the comment section. I'll be very glad to answer you guys.